Hello students, myself Dr. Kavita Verma, Department of Physics, Patna Women's College, Patna. My lecture is on the topic transistor. The outline of my lecture is: what is transistor, transistor terminals, types of transistor, some facts about the transistor, transistor connections. When a third doped element is added to a crystal diode in such a way that two p-n junctions are formed, the resulting device is known as transistors. The transistor is capable of achieving amplification of weak signals in a fashion comparable and often superior to that realized by vacuum tubes. Invented in 1948 by J. Bardeen and W. H. Brattain of Bell Telephone Laboratories, USA. Transistor is now became the heart of most electronic applications. A transistor consists of two p-n junctions formed by sandwiching either p-type or n-type semiconductor between a pair of opposite type. Accordingly, there are two types of transistors, namely NPN transistor and PNP transistor. In each type of transistor, the following points may be noted. These are two p-n junction, therefore a transistor regarded as a combination of two diodes connected back to back. Second, there are three terminals, one taken from each type of semiconductor. Third, the middle section is very thin layer. This is the most important factor in the function of transistor. Origin of the name transistor, from where it has come. When new devices are invented, scientists often try to devise a name that will appropriately describe the device. A transistor has two p-n junction. As discussed later, one junction is forward biased and the other is reversed biased. The forward biased junction has a low resistance path, whereas reversed biased junction has a high resistance path. The weak signal is introduced in the low resistance circuit and output is taken from the high resistance circuit. Therefore, a transistor transfers a signal from a low resistance path to high resistance path. So, the prefix trans means the signal transfer property of the device, while Easter classifies it as a solid element in the same general family with resistors. Naming the transistor terminals. A transistor, whether it is PNP or NPN, has three sections of doped semiconductors. The section on one side is the emitter and the section on the opposite side is the collector. The middle section is called the base and forms the two junctions between the emitter and collector. So, what is emitter? Emitter, the section on one side that supplies charge carrier, either it can be electrons or holes, is called the emitter. The emitter is always forward biased with respect to base so that it can supply a large number of majority carriers. In figure, the emitter P-type of PNP transistor is forward biased and supplies hole charges to its junction with the base. Similarly, the emitter N-type of NPN transistor has a forward biased and supplies free electrons to its junction with the base. Now the collector. The section on the other side that collects the charges is called the collector. The collector is always reversed biased. Its function is to remove charges from its junction with the base. The collector, that is P-type of PNP transistor, has a reverse bias and receives hole charges that flow in the output circuit. Similarly, in the figure 2, the collector N-type of NPN transistor has a reverse bias and receive electrons. Now the base. The middle section, which forms two p-n junctions between the emitter and collector, is called the base. The base emitter junction is forward biased, allowing low resistance for the emitter circuit. The base collector junction is reverse biased and provides high resistance in the collector circuit. Now coming to some facts about the transistor. Before discussing transistor action, it is important that the reader may keep in mind the following facts about the transistor. First, the transistor has three regions, namely ammeter, base and collector. The base is much thinner than the emitter while collector is wider than both. However, for the sake of convenience, it is customary to show emitter and collector to be of equal size. Secondly, the emitter is heavily doped so that it can inject a large number of charge carriers, either electrons or holes, into the base. The base is lightly doped and very thin. It passes most of the emitter injected charge carriers to the collector, and the collector is moderately doped. Third, the transistor has two PN junction, that is, it is like two diodes. The junction between ammeter and base may be called ammeter base diode or simply the emitter diode. The junction between the base and collector may be called collector base diode or simply collector diode. Fourth point, the emitter diode is always forward biased, whereas collector diode is always reverse biased. Fifth, the resistance of emitter diode, that is forward biased, is very small as compared to collector diode, that is reverse biased. Therefore, forward bias applied to the emitter diode is generally very small, whereas reverse bias and the collector diode is much higher. Now coming to the transistor symbol. In the earlier diagram, the transistor have been shown in diagrammatic form. However, for the sake of convenience, the transistors are represented by schematic diagrams. The symbol used for NPN and PNP transistor are shown in figure. Note that emitter is shown by an arrow which indicates the direction of conventional current flow with the forward biased. For NPN connection, it is clear that conventional current flows out of the emitter as indicated by the outgoing arrow in the figure. Similarly, the PNP connection, the conventional current flows into the emitter as indicated by inward arrow in the figure. Now about the transistor action. The emitter base junction of a transistor is forward biased, whereas collector base junction is reversed biased. If for a moment we ignore the presence of emitter base junction, then practically no current would flow in the collector circuit because of the reverse bias. However, if the ammeter base junction is also present, then forward bias on it causes the ammeter current to flow, and it is seen that this ammeter current almost entirely flows in the collector circuit. Therefore, the current in the collector circuit depends upon the emitter current. If the ammeter current is 0, then collector current is nearly 0. However, if the current is 1 milliampere, then collector current is also about 1 milliampere. This is precisely what happens in a transistor. Now we shall discuss this transistor action for NPN and PNP transistor. So, working of a NPN transistor. The NPN transistor with forward bias to ammeter base junction and reverse bias to collector base junction. The forward bias causes the electrons in the N-type ammeter to flow towards the base. This constitutes the ammeter current IE. As these electrons flow through the P-type base, they tend to combine with holes. As the base is lightly doped and very thin, therefore only a few electrons, that is less than 5%, combines with the holes to constitute base current, that is IB. The remainder, more than 95%, cross over into the collector region to constitute collector current IC. In this way, almost the entire emitter current flows in the collector circuit. It is clear that emitter current is the sum of collector and base current, that is IE is equal to IB plus IC. Similar is the working of PNP transistor. So this is shown in figure 2. Figure 2 shows the basic connection of PNP transistor. The forward bias causes the holes in the p-type ammeter to flow towards the base. This constitutes the emitter current IE. As these holes flow through the n-type base, they tend to combine with the electrons as the base is lightly doped and very thin. Therefore, only a few holes, less than 5%, combines with the electrons to constitute base current IB. The remainder, more than 95%, cross over into the collector region to constitute collector current IC. In this way, almost the entire ammeter current flows in the collector circuits. It may be noted that current conduction within PNP transistor is by holes. However, in the external connecting wires, the current is still by electrons. The input circuit, that is emitter base junction, has low resistance because of forward bias, whereas output circuit, that is collector base junction, has high resistance due to reverse bias. As we have seen, the input emitter current almost entirely flows in the collector circuit. Therefore, a transistor transfers the input signal current from a low resistance circuit to a high resistance circuit, and this is the key factor responsible for the amplifying capability of the transistor. So, there are three leads in the transistor, that is ammeter terminal, base terminal and collector terminal. However, when a transistor is to be connected in a circuit, we require 4 terminals, 2 for the input and 2 for the output. This difficulty is overcome by making one terminal of the transistor common to both input and output terminals. The input is fed between this common terminal and one of the other 2 terminals. The output is obtained between the common terminal and the remaining terminal. Accordingly, a transistor can be connected in the following 3 ways: common base connection, second common ammeter connection and third common collector connection. And each circuit connection has specific advantages and disadvantages. Thank you.